I am Ansley and this is my Fluent Project 3 Case A. So, we want to start with dragging Fluent here, making a new case. Right click, set this to 2D, click right click, new design model. There we go. Set the Z normal. And now to sketch, we want to sketch our cylinder first. And it should have a diameter of 1 meter. Diameter. Make it 1. And then we want to make these center lines. For now, we will delete them later. Dimensions horizontal. Set this into 25. And this one to 25 as well. Now I want to make a rectangle. And go to constraints midpoint. Click that, click this, click that, and click that. There we go. So now we have a square that is 50 by 50. And once we're done with that, we're going to go to concept, search for some sketches, click that, apply, and generate. And that would be it for the design model part geometry. So now we're moving on to meshing. Already have the meshing window open. So now what you want to do is you want to right click on mesh, insert, go to method on Mac, click that, apply, and then for method you want to do triangles. Yep. And then generate. See how that looks. Start. Yep. And then you want to go to sizing. I click the edge, insert sizing, click on your hole, element type, number of divisions 200, capture curvature no, and set the behavior to hard. Yep, and then generate. You can ignore that error. Yep, and then you want to do an inflation. So you want it along the face. Let's see. First layer thickness. First layer height 0.003. Maximum layers 20. Yep. And then generate. See how that looks. Let's start. There we go. So yep, that looks pretty good. So that would end the meshing segment. Little edit. I forgot to set the maximum layers to 65 actually. So now it should look better. Right? Yeah. Okay. Oh, so this will be the last add-on segment for real this time. I just changed the meshing to 0. Go to mesh, and then you change this element size to 0.15 meters. Click generate. It'll take a while, but it should come as this big black block, and that should be the official end of the meshing segment now. Okay, so a small correction for the meshing again. So for the no, for the inflation, I forgot to set this part. So you want to set the boundary as this. You want to click this for the boundary. Right, and click that for it. And after you mesh, it should look like this. So yeah. So now I'm still in the meshing window, and now we're going to create our named sections. So make sure you can select the edges. Select your edge, insert, create name section. Call this the inlet. Select your top and bottom wall. Create name section. Call these the symmetry. Select this. Call this the outlet. And then select your cylinder. Create name section. Call this the wall. And yep. Okay, that will be the end of the creating name sections. So we are now moving on to the setup part of the project. So which one are you going to? This is for case A, so it's going to be inviscid flow. So I'm going to set this to inviscid. Okay. And then I personally changed my fluid into 1.2 density. Change, close. Boundary conditions, inlet. We have an inlet velocity of 5 meters per second. So go into here, click on both 5, apply and close. Internal, it should stay that. Outlet, you want to prevent reverse flow. Apply, close, symmetry. And then reference values. And compute from the inlet. And then initialize. And then now we have to run our calculation. Number of iterations, go to 200. And calculate. Okay, so now that that's finally done, we can now go into our report. So we can go to report definition, go to new force report, drag coefficient, print console on the wall, compute, and that is our drag coefficient. And then we can also make the pressure and the velocity plots. So go to XY, pressure, this should be pressure coefficient, its long circle should be curve length along the wall, save and plot, and that is our pressure curve length. You can also write this to file to send this to Excel or something so you can load it for later on. And then you can go into velocity magnitude, keep everything the same, save and plot, and that is our velocity plot. And we are done with the setup. So now I'm in the results. What we want to do first is we want to create our pressure and velocity contours. So to contour 1, location symmetry 2, variable velocity, global contour 110, and apply. And yep, that is our velocity contour. And then we can also create another contour, this time a pressure contour. Pressure contour 110, location symmetry, apply. And yeah, that is our pressure contour. And then we can also create the streamlines for our velocity. The main streamlines start from the inlet, 250. Yep, apply. And now we see the streamlines. That would be it for case A.